We're looking at number 3. The largest number that'll go into all of those is a 6. Variable-wise, just an n. So we're 6n, and that's 6 divided by 6 is just a 1. N to the third divided by n is n squared. 48 divided by 6, we did it over there. So that's going to be 8. N squared divided by n is n. 36 divided by 6 is 6, and the n's cancel. And then the next one, will 8 go into all 3 of these? It does, so 8's our greatest common factor. There's no m in this one, so we can't take out the variable part. So it's just m squared minus 8m minus 2. Andrew, can you put the phone away? Okay, any questions there? Okay, put that aside. We'll work on it some more tomorrow. I want you to take out your notes notebook or a piece of paper to take notes on. We're starting Unit 9, which is solving quadratics using the quadratic formula. The part of what we're going to find out later is that the quadratic formula has a square root in it. So we have to learn how to, or remember how to simplify radicals, which radicals is just another name for square roots. Okay. So the first thing we need to know is, before we can start to simplify radicals, is what are prime numbers? Well, prime numbers are numbers that are divisible only by 1 and itself. So they don't have any other factors. That's what a prime number is. So our first prime number is 2. Because it doesn't have any other factors besides 2 and 1. And then our next prime factor or prime number is 3. Would 4 be a prime number? No, because 2 will divide into 4, right? What about 5? Yes, because there's nothing else that will divide into 5. And then 6, no. 7, yes. And then what's the next prime number? 11. The next one? 12, no. 13? 13. Let's keep going, a couple more. What the next one would be? 17. 19, 23, and then that keeps going. You know, the higher we go, the more spread out they'll be. But for what we're going to be working on, that'll probably be good. We might come across something a little higher, but probably not. So we're going to find the prime factors of a number. So say like 20. We want to find out which of these numbers all multiplied together will equal 20. So there's two ways to do that. There's something called a factor tree. Does that sound familiar? Or a factor ladder. Now they're both basically the same, but we're going to I want you to try using the factor ladder. And the reason that is because when we go into simplifying radicals, it makes simplifying the radicals easier. So let me show you how we do that. So just go over here and write 20. And then we're going to kind of put around the 20 like an upside down division. And then what we're going to do is we're going to look at our first prime number. Our first prime number is a 2. So we're asking ourselves, will 2 divide evenly into 20? So can we do 20 divided by 2 and come out with a whole number? We can. 20 divided by 2 is 10. And then we're going to ask ourselves, is 10 divisible by 2? So we put another upside down little division thing. Is 10 divided by 2? Yes. We take 10 divided by 2 and we get 5. Well, and then here I notice that 5 is one of my prime numbers. So if you get a prime number, you stop. So our prime factorization of 20 is 2 times 5. So let's look at the number 150. So divide by 2. If we can. Can we divide by 2? 150 divided by 2, and we get 75. Now we're going to say, can we divide 2 into 75? No, it comes up with a decimal, right? So then we're going to go to our next prime number. What's our next prime number? 3. So is 75 divisible by 3? Yeah. Okay, so we're going to do 75 divided by 3 is 25. Then is 25 divisible by 3? No. So I go up to my next prime number. Is it divisible by 5? $25 divided by 5 is 5. We got a prime number. So we stop, and the numbers down the side are all of your prime factors of 150. So it's 2 times 3 times 5 times 5. And if you check those on your calculator, 2 times 3 times 5 times 5, you get 150. How about $162? So go ahead and try it. You're going to use 2 until you can't use 2 anymore, and then start with 3, 5, 7, 11. Go from there. I haven't done this one yet, so I'm not sure how far you can go. Just go ahead and let's see where you can get. Till you come up with a prime number or you can't find anything that'll go into it. Okay, is this divisible by 2? Yes or no? Yes. 81. And is 81 divisible by 2? No. So we go to the next number. The next number is 3. Is 81 divisible by 3? $27. So the only numbers we're putting here on the outside are those prime numbers that we've listed up above. So is 27 divisible by 3? Yes, it's a 9. Is 9 divisible by 3? Yes, by 3. We got a prime number, so we stop. So the prime factorization here is 2 times 3 times 3 times 3. 1, 2, 3, 4. One more. Okay, let's do one more. Let's do the prime factorization of $441. It's not divisible by 2. And try 3. Keep trying 3 till you can't use it anymore, and then go up to your next number. Okay, so did 2 did not go in, right? So did 3? 441 divided by 3, 147. And then could you divide that by 3? Looks like it. Now is 49 divisible by 3? No, we get a decimal. Is it divisible by 5? No, we would get a decimal. So the next prime number going up our row was 7. Is 49 divisible by 7? Yes. And it's 7, and 7 is one of my prime numbers, so I stop. So the prime factorization here is 3 times 3 times 7 times 7. Okay, any questions there? Okay, so let's bump it up and let's do actual, now we're going to do, let's do the square root of 180. Well, you know what? Wait a minute, I want to do something different first. So what about the square root of 25? So let's go back. What is the square root? What is it asking for? It's asking what number multiplied by itself equals 25. Well, 5 times 5 is 25, right? So the square root of 25 is 5. Now on your calculator, you find that square root button. Mine is right here in this calculator. Some of the other calculators at some place a little different. But if you hit the square root, then 25, and hit equals, and you're going to get that 5. So find the square root on yours. If it's not right there, make sure you can do that. If you don't have a calculator, go get one. So what about the square root of 81? The square root of 81 is 9, because 9 times 9 is 81. What about 196? Well, if you can put it in the calculator, we get it's 14, because 14 times 14 is 196. What about 256? Some of these numbers you probably don't recognize if there's what we call perfect square roots when they come out to a whole number. So the square root of 256 is 16. So these are what we call perfect square roots. Because the square root of that number comes out to be a whole number. And one of the things to do when we start to simplify square roots is just check first and see if the numbers come out as a perfect square root before you start doing the process that I'm going to show you how to do next. So when we have to simplify not perfect square roots, now the process is a little different. So going back to the number that I put down originally, square root of 180. So if you do that on your calculator, if you put in the square root of 180 and hit equals, it's a decimal. Well, for the work we're going to do, we're not going to change square roots into decimals, only into whole numbers. What we want to do is we're going to do a little process, and we're going to take all of the perfect square roots out of this. And the way we're going to do that is we're going to, first of all, prime factor it using our factor ladder. So take 180 and let's prime factor this using that factor ladder. Start with 2. 180 divided by 2 is 90. Divide by 2 again. 90 divided by 2 is 45. Will 2 divide evenly into 45? No. Will 3 divide into 45? Yes. You might see 45 and think, oh, it's divisible by 5. But don't go to 5 until you've tried 3. So 45 divided by 3 is 15. Is 15 divisible by 3? Yes. And then that will be 5. So this is 2 times 2 times 3 times 3 times 5. Now, notice here, so this is, we're still under the square root because we're doing the square root of this. So what is 2 times 2? 2 times 2 is 4, right? What is the square root of 4? 2. So that's my one of my perfect square roots here. So I'm going to take the square root of 4, and it comes outside of the square root. So the square root of 4 is 2. Then there's another pair. 3 times 3 is 9. And what is the square root of 9? 3. So notice for each of the pairs, one of those numbers comes out. Now, the 5 doesn't have a pair. It's not a perfect square root. It stays under the square root. So now those 2 that were out in front, 2 times 3, we can multiply those together, and that becomes 6 square root of 5. So that's your simplified square root. That's the work we're going to be practicing today. So let's do another one. Let's do the square root of 32. So go ahead and prime factor it. Use 2 until you can't use 2 anymore. And then try something else. So it looks like I get 5 2s there. Did you guys get that? And then we can circle pairs. So 2 times 2 is 4. The square root of 4 is 2. Or for every pair, we just pull out one of that number. There's another pair. This 2 is left over, so it stays underneath. So the answer there is 4 square root of 2. Let's look at just a couple more, and then I'll give you your assignment. So let's do the square root of 63. So we want to prime factor it. Is it divisible by 2? You don't have any questions on what we're doing? Okay. So it's not, is it divisible by 3? Yes. Is 21 divisible by 3? Yes. And you get a 7. 7's the prime number. So I get 3 times 3 times 7. Are there any pairs? There's one pair of 3s. So we're going to pull out a 3 because we're taking the square root of 9. That's 7. Stays underneath. Let's try another number that's a little bit larger. So the square root of 252. Go ahead and take that all the way through. I'll leave that up there. Go ahead and try that one all the way through. Start with 2, then look to 3, then 5. Okay, so there actually is no assignment today. We are just going to practice together today. Tomorrow you'll have an assignment with us.